Hi everyone, it's Michał from Strusoft, and I would like to welcome you all to our Impact Showcase for Impact Design in the autumn of 2025. More like winter in Poland, but still, um, that's the session for the end of our calendar year, and this will probably be the last session in this year. And so next one, well, we'll see each other probably sometime beginning of next year. Now, we have some agenda for today, and what we'll show you, some of you will know this, but some of you will see this as a new feature, and those who don't know Impact, I'll show you how to place cranes, how to define cranes and add them within your CAD design. And why would you want to do that? Well, if you are responsible for also the erection of your product produced elements, then of course it's a good idea to maybe verify where the crane needs to be placed, and as such have some being able to verify whether the carrying capacity of the crane is sufficient at particular radii of the crane. We will also, of course, model some elements. I'll show you how we can do that efficiently. A couple of different ways of how to model and edit elements within Impact, just so you have a nice little overview. I'll show you also how to place casted materials as well, and those can be added in various multitude of ways, and I'll show you just some of them. We'll talk a little bit about rebar templates as well, so how to define reinforcement in elements that require that reinforcement. Of course, we will save the elements to the database, and I will also show you a nifty little, maybe not a feature per se, but a, say, workflow for reusing elements that you've already designed once. So some that are in your catalog, and you can use them a multitude of times in different projects that maybe are hard to model initially. In order to save your time, modeling, then you can of course reuse some elements. Now, we also generate shop drawings, as you see on that screen here, and we'll talk briefly about some rebar tools as well. Some of you who've attended our user conferences or watched the recording of the user conference know we've talked a lot about something called OBJ files. And those OBJ files allow you to display the reinforcement and casting materials inside Project Manager for visual inspection and visualization of your projects. So I'll show you how easy it is to turn that on, and as well show you where to change specific settings, so it's easy for you to not have to remember about actually creating those files manually. We will also, of course, talk about that preview, and you'll see that 3D preview of the elements with reinforcement as well at the end of the session. So without further ado, let's go ahead and actually jump straight into our little test project. I'll close the element properties for now in AutoCAD, and here is our today's canvas for our work. I'll start simply by placing some elements for your project. That will be a simple construction, but it will encompass a couple of different element types, just so there's some interest in this presentation today. So first off, we'll start off with columns. And columns, we'll use typical rectangular ones, and those will be 50 by 50 mil, and there's some reinforcement in it, and I'll go back to that a little bit later. The height of those columns, I want those to be 6.5 meters high. By default, the value that pops up here is basically the value of your floor height that you have defined in Project Manager. But for now, we won't be talking about that. So just a short little overview as well on what you can do in your columns. You can also, of course, rotate a column. Now, if that would be a rectangular column, then we could change the rotation of that, and I'll use that feature slightly later. Maybe not even rectangular column, basically. I'll show you a little workaround regarding lifts that we can have a look at. You can change the column top as well. So for example, you can have a corbel for your wall, or if your corbels on tops look like this, then of course you can edit it according to that sketch here. But you can of course maybe just have like a not a corbel, but rather a lifted, say, segment of a column or half a column erected to just cover maybe the face of the beam on top of it. And sections, that's a feature, of course, that allows you to change the section mid-span of a column. So if you need a bigger section, like maybe on the bottom or near the column foot, then of course you can do that, or maybe near the column top as well. Last section is the model tab, which allows you to change some parameters like the input point of your column, offset of that insert point, so you can be very, very precise. There's a dot in the middle here. So, for example, if I go 150 here and 150 here, now my insertion point is here. So if I clicked on that grid, sorry, then basically my column will be offset by this exact value. But let's go back to default from middle center. And of course, there's some different options for you for the placement as well. And offset from bottom and from the top. So basically, that would either lift or lower your column, depending on your requirements for the particular case. About the reinforcement, we'll go back to that slightly later. So those will be our reinforcement templates. For beams and columns, they work slightly different than for walls, but no worries. I'll explain on the way what's happening. With that, let's actually start placing some columns. So I'm going to place those on the axis, and I'm actually going to rotate our columns by, I think this value should be good. And I'm just going to stop the placement right now, just so I can simply copy those columns. Why am I doing that? Well, simple, just so I don't have to manually place that rotation every single time that I'm clicking. And you can see it's super easy to actually place the columns like that. I'll just rotate the view slightly so you can see those columns are placed. I'm not exactly fond of the placement of the lifters that came up this way, but we'll fix that in a second. Right now, I'm going to basically just copy over those columns for us, or rather mirror them. There's a mirror tool, and there's a mirror tool available for all element types. There's your mirror for beams, columns, your linked elements, your hollow cores, slabs, and walls as well. So you can mirror all the elements that you really need, and it's very simple to use. I've already selected the elements, and what I'll do is I'll just select the mirror line, and I don't want to remove my elements. Just FYI, once the elements are mirrored, the lifters do not get mirrored. So that's one thing that's worth keeping in mind, that lifters will be staying in the same position. But what I want to do is I want to place those lifters on the outside of the building. So I'm just going to, I could double click on the selected elements, or I can go and select the option to edit, click on the properties. What I'll do is I'm just going to rotate that counterclockwise and update lifts like that. Super easy. There's one way. That's one way of doing it. Of course, you could go edit casting material or edit lifts from one of those options. That's also a good way to do it, but for me, it's easy to do it this way. I'll also add a row of columns, small columns here, just for our other types of elements that will require some support. Now I'm going to use the same type of column, and our floor height is 260, and I'll just use this one, this floor height. And I need to do this column here, and I want my lifters, I would say, not exactly this location, but exactly the opposite, but that's fine. I'll I'll just double click on that and rotate that counterclockwise and update left. That's what I wanted, and that's fine. I'll just now base copy that maybe through here, so I'm sure that I'm selecting on level 0 of our building, and hopefully everything is properly aligned. I'll just make sure those are smaller columns for us. I wanted to make that rather simple. Now with that done, I'll go ahead and start placing some beams. It's gonna be super easy. I'm just gonna place some legend beams, so your normal type of beam. And what I'm going to do is use for now just a legend beam, one ledge, and this one. And I'm gonna go to model and see what the elevation is for my bottom placement. And actually that's what I want. That's my elevation, but I want to be sure that my elevation is properly proper inside the model. With AutoCAD, it's critical that you snap to good points. Of course, you can use AutoCAD tools or Bricks CAD tools for that matter as well to lock yourself to a specific plane. But to make things easy, you can select lock elevation here, and with the elevation that's specified in here, of course, you can change that manually to like 5,000 if you really want. But we'll go to 2120 for now, and I'll just keep the alignment as center on the bottom, which will make it look nice in the model. One thing of note that's worthwhile to know is the direction in which you place a beam, a legend beam, matters, and basically all the elements impact matters, because the direction you're starting putting the elements, the long elements, by say placing them along lines or polylines, determines where the front and back faces of the elements are, or left or right sides of those elements are. So if we go clockwise, so from bottom to top, you can see that our ledge is on the right side, exactly where I want it. If I went the other way, then of course the ledge gets moved to the other side. Would be easy to fix anyway. We could mirror that and mirror the element and it would fix itself. But before we do that, I'll also apply an offset. And offset, I would like to have a 20 mil offset from the end of the column, and that's same thing on the other side. This will make sure we can just make sure that there will be no collision or fitment issues on site if we apply some offset. And it's just a matter of doing that same thing here. And I'm going to go to the other side to get those done here as well. Like that. And since we are locked in the elevation, all the beams are placed with the bottom exactly where we want them to be. Okay, and let's go to the top. You may notice in our view, that since lifters are placed automatically in the columns, they're also placed automatically in the beams. So that's very, very convenient for us. That's because of the settings that we have. We have defined casting materials. We have defined the lifts as well. We have defined in the elements. We have defined basically the way they are placed every single time. So it's easy. We don't have to think about it consciously. I'll define use another type of beam. That's going to be an inverted T with this particular reinforcement template. And I'm also going to be locked on this elevation, and I want some of those. Beams here. In my case, in this particular case, we don't really care about the orientation, maybe for those beams, because well, they have ledges on both sides. So exactly which is left or right doesn't particularly matter in this case. I'm going to press space, and of course I could continue the placement one by one and just place them, and it would be fine. It doesn't really matter. But what I'm going to do is I'm just going to copy those beams again from some base point like that, and it's super easy, super convenient to do that. All the elements are there. Now, you might ask, but how are we going to support those beams on those columns? Well, with corbels, obviously, but how do we add that? Well, a couple of options. I'm just going to copy that column over. I'm just going to copy that column over in the side just to show you. Well, there's the manual way. You can just click the option, add a corbel. You can click on the column. You can add a single or a double-sided corbel or a multiple-sided corbel if you wish, of course. And there's like definitions for different corbels. You can add those definitions, edit the existing ones, add ones, change the sockets for the for connecting. Change the casting materials that you use, change some settings, specify which side of the column the corbel is on. Obviously, you can change that after the fact, not a problem. So let's do that, and that's a corbel, and yeah, that's it. You can add another one as well if you need. You can change the elevation of that corbel, maybe 5,000, and maybe this time on the right side, and add that, right? And exit. And that's it. That's the column with those corbels. But we don't really want to do that. Why? Why would we want to do that if we can do all this this labor automatically? And it's as simple as using the other option that we have, draw corbel from element. What will happen is Impact will recognize which elements are columns, which elements are beams, and it will try to place the corbels accordingly, according to that recognition. So I'm just going to use that option, select everything that we have, and press space. And that's it. We pop up with a single corbel. It's easiest to do it this way, as it will automatically place a single corbel under every beam. All right, so super easy and super convenient, and just a matter of selecting whether we want to use the settings that are proposed here. Of course, we can edit stuff according to the settings as well. So I'm just going to click OK here, and I want to specify a gap between our corbel and beam that we're supporting, and that's going to be 10 mil, and I'm going to do just that. Except that, what happened here, all the elements now have corbels. It's good. Okay. Nothing stops us really from, of course, adding some additional beams for stability in the other direction, just so those are not really individual frames. So really not an issue. We can just go ahead, for example, draft those beams at different level, some stability beams, just your rectangular ones, like that. Maybe some, okay, maybe those ones, and let's lock them at a level maybe 450, like that, like that. And again, just a matter of quickly placing those elements. We don't need more. And again, let's just mirror those for our convenience, like that. You can see a couple of minutes, and basically almost the whole model is done. What I'm going to do, select those elements, and you can see the flexibility as well. I first selected the elements, now I'm going to add corbels. Impact still works, it still recognizes that, and the gap is going to be the same, and like that. Super quick, super easy, super convenient. Done. That's how we can do it. Now would be best if we added some roof beams. Now, here's where I come to the topic of actually using saved elements in Impact. Because obviously we can save the elements to the database. We will have those elements saved in the database for this particular project. But maybe you want to reuse an element. So for example, you can create a project that contains your catalog elements, your different elements that you can produce or that you typically use or would want to reuse multiple times. And simply you can create a geometry for that. Like an example here. I have say a girder that works for this particular case. It has a complicated geometry. It has opening in the web of it. And it might be complicated to add the reinforcement to it or define it for this specific girder. Maybe it's something that you don't want to do every single time you have this particular girder with this particular span. So nothing stops you from actually copying this whole thing from your project with a base point. Just copy that, and inside the project, just copy it, and copy it multiple times. And then, since this element is unmarked, it really doesn't matter. You can save it. It's probably yay too big for this particular roof. I think our span here is about 9 meters or slightly more maybe. So maybe that's overkill for this particular girder, but still, the case still stands. You can have that geometry prepared in another project. That file here is just a file that I've created in another project. And here I have an element that's modeled and it's ready to use. It's got some definition. It can have defined reinforcement, the casting materials and whatnot. And it's just a matter of actually copying that in. And that's it. You don't have to worry about an element like that in this particular case. So makes it slightly easier makes it slightly easier for us to model. But maybe that's it about the beams and columns. Let's move to other element types. What I would like to do as well is I would like to isolate that. Let's go and isolate that. Okay, go back to the top. I always forget that it's much faster on the left side here. So we're going to make it easy. We're going to use hollow cores, and we're going to support those hollow cores on the ledges that we've created here. Now, I'm just going to quickly verify the level that I'm at. Everything should be perfectly defined for the project, of course, because I prepare myself for those presentations, but it isn't always the case that it works. And let's change the UCS view. Let me just check. 236. Let's check the Z offset. 2360. Okay, 2360 UCS world. Again. Let's make it super easy. So I have also defined some hollow cores. Sorry, those are the hollow cores. Let's use a typical 19 section that's predefined and impact. And for those, of course, you can define strands. I'll show you how to do that in a bit. But let's quickly place some of the elements. I'm not going to specify a color line. What I'm going to do is I'm going to specify a window, and I'm going to specify that window from here to here, and we don't have to worry about the column here that we are cutting through. Doesn't really matter, not at this stage. I'll show you why. And specify the support. I think 100 should be good. 0 there and 100 here. So what you see me here doing is actually extending support length on our hollow cores. And just do that. No slope. Of course, rotate that 90 degrees, and we get a proposal for our layout. And yeah, that's going to be perfectly fine for us with that layout. So I'm just going to accept that, continue, apply both of those hollow cores, and the hollow cores placement is done. What we will do now is we will edit those two hollow cores very quickly to make sure that we are actually cutting around the column that we are passing through here. And we can do that super quick with our recess tool. there's a draw recess filling, where you can manually draft it over and use that like a rectangle or a polyline to cut that opening out. But you can draw a recess from element, which I'll use, and I'm going to select those two hollow cores to subtract from. Yes, and elements that I want to subtract. Well, I want to subtract this and this column, like that. I'm gonna get asked how much offsets do I want from those columns, and that's gonna be 50 mil. I'm not gonna change a thing here. Just going to accept that, like that. Our hollow cores are now cut around the elements, and that was super fast. What I'm going to do is I'm going to draft another set of hollow cores with a window, and it's going to be here. And why is that? And that's because that's a different set of hollow cores, slightly different support lengths, or other spans. So that's going to be 0, 100, 0, 100, and accept that, rotate like that, Control, apply, and apply, like so. We're going to do one more thing, again, the cutout, those, subtract this one, and accept that. I've done it fast, so we don't waste too much time, just so you can see that we can do that. One more thing. We're going to actually add lifts to some of those. You can see we have two cut slabs, so of course this side cannot be caught by a hook. The side with a saw mark, of course, a saw symbol, cannot be caught on by a hook. So we'll just manually add lifters to those hollow cores. There's an option. We can leave those two channels to be filled, and of course you can put in the lifters in those hollow cores. So we'll just add that. As you can see, lifters have been added to those particular hollow cores. Super quick, super easy casting material additions to our elements. Now, let's finish those hollow cores very quick by just mirroring those hollow cores along our axis of mirroring. And let's keep the originals like that. All are done, and we can end object isolation. And you can see how fast and incredibly easy that is. Now let's go back to the reinforcement templates. Let's go do that for columns. It's going to be identical to beams, really. I don't have any sections defined for this project, but I have some sections defined for for our standard in general. So I'm just going to edit that. And in the definition of a column, you can see there's a variety of properties. So there's the size of the element, there's chamfers, if you want for your geometry to add chamfers, some descriptions to those chamfers as well. How do you want to add the lifting, depending on the mass of the element, what type of lifter is added according to a mass, how it's placed on the elements, of course, and specify whether you use 2 or 4 lift points. 4. There's a scale, automatic scale on the drawing for the elements, some MISC settings, and also the reinforcement tab. And that's going to be where you would create reinforcement. So here, there's 2 different layouts of reinforcement created in the templates, and of course you can create a new one. Say new RC template. I'm going to name it like that just so you can see, but of course you will name it something that makes sense to you. And like that, you get another window that pops up. You specify what type of bar mark you want to use for your stirrups. It can be, for example, an N. Right, those are maybe not big enough. Maybe let's go L actually. That's going to be this one. So of course you will need to define actual bar marks So again, I'm adding some new ones. I'm going to maybe add that to the project. New one, just so you can see that. And you would select a shape code that makes perfect sense for you in this particular instance. That's like a shape code 21. So let's make it 40, 400, 400, and like 50 and 50. And for example, that's going to be a shape code for us. Use this one in particular. And of course, that one's not common for now. Import, export. Okay. That should be good. Okay, so that worked, and you would change the placement of that. Why would it be 50? 50. Something like that. So again, you find the insertion point for your bar mark, you place the bar mark as well, and then you would define how those stirrups are placed, and you have your dimensions here that you would input, and as easy as that. So that's your stirrup location. And for your main bars, you've got the straight bars option. Let's go, actually do 60, I think should be fine for this bar mark. And like that, you can define whether you need some additional bars, left, right, and whatnot. And that's how you define your reinforcement template for your column. That's it. Of course, you can add multiple layouts of stirrups. You can specify what type of shape code that is, and which bar mark that is. So there's a multitude of options for you to specify how you want to reinforce your elements. And that's for beams and columns. I'm not going to show the column option. I mean, that's going to be, if I go, sorry, not here, but here. Let's go common and just get one of the beams, rectangular beam, maybe just one of those. The tab is basically identical, works basically the same way. So yeah, you can work with it. And of course, if you need changes to anything, like the position of your bar, every single particular bar, you can click on its location and you can change the position. You can add or remove rebar from here as well as here. If you need to remove a stirrup, then you can of course remove that. As mentioned, you can add multiple stirrups in a beam, different types of stirrups. So if you need like another one in the middle here because your technology, you work in such a way, and of course you can do that. So let me close that. With that, with the reinforcement templates, for now, let's close the reinforcement templates, at least for beams and columns. Now we'll add some walls here, our sandwich panels actually. So we will do sandwich panels in this section of the building, and I'm going to click on this start point, right? And I'm going to change the properties because I will be using a 42 size sandwich wall. That's here. Height of that is fine. And there's also a reinforcement template here. Why the reinforcement templates? So you don't have to think about manually adding all the reinforcement into your elements at the drawing stage. The reinforcement template will be applied at the moment of you drafting the element, once it's complete, and you can go open the drawing once it's of course prepared in Impact, and you can go ahead and actually edit that reinforcement to make it fit your needs, of course. So with that, let me go ahead and actually start placing that. And I don't want to place the elements this way. I actually want to go by center, by the axis, and I'm going to add big walls here. You might ask, why are the elements popping up red? And that is because the elements don't conform to the max allowed either size or mass of the element that's defined in Project Manager. So if the element is too big, Impact will simply warn you about it. it will warn you in such a way, oh, and I've noticed that I've input the panels incorrectly. So sorry, I'm going to quickly delete that. Why? Some of you probably maybe noticed, but the bracing anchors are on the outside of the walls. That means that our inner panels are on the outside. That's very often something that I forget. That's the directionality of your inputs in CAD, and it's honestly, it's much simple to just start over. I must add, it's ready. Hold on, something. Oh, my, I got frozen for some reason. Super slow. Hopefully I'm able to do that for you. We all need to restart now, bad. Super slow for some reason now. Oh boy, no. Oh, I'm sorry about this. It's very good, Dad. Hit it again. I drafted it incorrectly. That's because my. Yeah, looks like that worked fine here. Yeah, that works fine. Okay. Okay. Something very weird happened. I just had to minimize my impact for a moment for it to start working. You can see while I'm placing walls, there's an arrow that's pointing out the inside panel. So what I need to do now, I just need to go rotate, and now my inside panel is on the inside, where it should be. And I'm just going to draft it like that. It's going to be quick and easy for us, like that. I don't worry that we are overlapping here. That's because we're going to both divide the panels, the big walls, into smaller panels. So we're going to be doing that, and it's going to be super easy for us. But before we do that, I'll just draft in some solid panels as well. So solid walls, start. I'm going to place them here. I'm going to change properties. I'm going to add a wall 20 centimeters thick, and again it's going to be like that. And this one will also divide. It's green, so both the size and what mass works for the element. That's fine. How can we divide walls quickly? Easy. There's the split wall vertical option. I will select this one and this one at the same time. That's because they are symmetrical. I want to specify a 20 mil gap between those panels, and Impact will immediately pop up with a proposal of what type of end, or rather, Impact will ask me if I want to apply an end cap to the elements. And yes, I want to do that in this particular case. So I'm going to do that here. And I will specify the breakpoints. I'm just going to click on those axes that I have and press spacebar. What will happen is we now have our walls divided, end caps applied. Why do we have end caps applied? Of course, to connect the elements and whatnot. I can do the same the other direction, but this time I will not be applying the end caps. And that's click and click. Those walls, 20 millimeters, but no end caps. None. It will just apply a straight, basically a straight end to a wall. So, like that. I'll show you why. Because now there's a couple of ways we can connect those elements and apply. I'll quickly go ahead and while I'm talking, do that in the background. There's a couple of ways we can apply cast-in materials to connect those walls together. Of course, you can go ahead and do that one by one manually. Time consuming, that's not the point of Impact. The point of Impact is to make it as easy for you as possible. So now I have those end caps applied to my elements. So there's a very, very easy way of applying the cast-in materials based on those end caps. And I'm going to do that. There's something we have called cast-in material templates, and I'm going to now select those elements with those end caps. And I'll show you that we have some defined recipes. There's a WD24 vloop, which is what I will use. What it does is, if I go into settings for that custom material template, it basically looks for the end cap that we have applied, and it places this casting material. And it looks how do we want to place that casting material. This one we don't really want to place on the top and the bottom, but on the left and the right, yes. So that's where we would be placing that. And that's where we have definitions of placement for this cast-in material, right? So that's the end cap for the sides, left and right, and that's the placement definition. So the distance from top and bottom, and how many we want of those. Maybe we actually want three sets of those cast-in materials. So we maybe will do it this way, like that. So we'll go 500, 500, and three cast-in materials, placing right. Let's offset that, but maybe on the right side by maybe 520 and 480. So they're offset, and three cast-in materials for us. So that's this one. Oh, sorry, this one. 520, 480, and three cast-in materials. And I've edited that, and I'll just apply that to the end caps. What Impact will do is it will automatically place those end caps for us, or those cast-in materials. And I've offset them slightly right now, so basically they don't collide one with another, those loops. And that's how you add cast-in materials super quick to the cast-in materials. Of course, to the elements. Of course, you can go do that by hand. Add a draw a cast-in material and add that out manually. Select the placement and whatnot. It's also super easy, so I can just show you as well. I can select an element, do that. Select the cast-in material that I want to add. Fixtures. Maybe that's some cast-in material. I'll just maybe add it. Yeah, and I would specify that's definitely not for a wall, but basically you specify the side of the of the element that you want to apply that cast-in material, and you've got dimensions as well, so it can be very precise. Let me not add this material to our wall and not ruin the project or make it difficult for us to edit stuff. It's of course not difficult to remove a cast-in material. You just click on a wall and click remove and get rid of it, simply put. So that's that. The other way of connecting the walls is actually using the connect wall. And this is also a powerful tool because you can select a joint. Impact will try to recognize a joint for you, and it will try to assign that joint with this particular cast-in materials on all the settings according to the connection. And that's the placing of that. Let me go ahead and actually do that this way. Cast-in material, just to make it different, I'm going to leave it at 2, so you know that those sides are different. And the origin of the joint, let's make it in the middle, and apply and update all, like that. Walls are now connected. I can do the same thing here. Oops. The origin of a joint, that's because we need to be somewhere in the midspan of that. Apply, update all. And this one, of course, you can follow along and do that for the... As you see that you are getting a preview of this. Soon we'll be done. Just do some corners as well. So I'll select the corner. and I'll just select the wire loops as well, assign that, click OK, and you get a preview. You can change the orientation of the of which wall is the covering one, covering the other one. So I'm going to update that as well. As you can see, the walls are being aligned properly like that, and I think that's the one that we used on the top. Should be similar. And as long as I'm in this window, I can go ahead and add those casting material. Right. So I'm just going to finish this, and what we'll do now is we are actually going to save the elements to the database. There's also, what we also could do is we could actually, we will do that. We will focus a little bit on the casting material templates, not casting material templates, but the reinforcement for sandwich panels. Since I'll be also right, so we've got our sandwich panels. Let's maybe go to the middle one. Go to properties. That's the reinforcement template for our sandwich panels. Here's the reinforcement templates, and we'll go to that. We'll go to common, and that's the WA00. Here you define how the meshes are aligned. Meshes of reinforcement are aligned in your sandwich panels. Here you define how you add reinforcement to the exterior of the wall, the corner reinforcement as well if you want some, and you can specify a shape code as well, and the opening reinforcement if there are any openings inside walls. Of course, the meshes that you use are defined as well here. So the type of rebar in the meshes, the spacing of bars between meshes, you define inside those meshes. And those meshes you define in the element and the mesh tab as well. So, for example, the one that we had before, here, you define that, basically the parameters of your mesh. You do that, calculate the mass as well for impact, and that's it. That's how you go ahead and do that. Let's quickly add an opening. As you can see, it's super quick and easy to add openings and impact. Select the element, let's go common and add the balcony door. Of course, I need to common export from local import from common import. Okay, this one actually we have to import. Let's use that. That's the balcony door, and for example we can specify the justify center, and for example midspan of this door, of this wall, we can do that. And with that, you will see that, for example, for this particular wall, the reinforcement has been added automatically once we open up the drawing. But before we do that, I need to actually start saving the elements to the database. So I'll save all the walls that we have. So our sandwich panels, and let's go with SW1 as a start number. We're just going to save those. This is going to take a short while to do that. In the meanwhile, while this is saving and while the other elements will be saving, once I save those, let's go hollow course, all hollow course. Let's save that. Okay. I'll go to Project Manager, and in Project Manager, under Project Properties, it's important to get the OBJ files and the reinforcement of the elements. It's important to make sure that one setting is popped up in the drawing option. Under under Layout, that's the automatic update of view 8 solid. To get automatically the contents of the element while you create a drawing of the element. Basically, you need to have a drawing of the element generated and a solid view of that element visible. And if there's reinforcement and casting materials in that solid view, then you will get the OBJ files to get the reinforcement in Project Manager. And that's the option here. So when you create drawings, both the casting materials and reinforcement will be automatically applied to a solid. And there's also another option in standard admin, which I will open in the background while that happens. Let's save ourselves also, not this. Let's save all standard walls as well. Those are only 3. Let's save the columns, which is not many. All the columns, like that. C1. That's just going to be just a couple, like that. Let's save all the beams, the non-stressed ones, and let's save all the pre-stressed ones, which are the big beams, big girders. Right. Let's go back to Project Manager to get the OBJ files as well. Under Settings, Variables. There's the auto export OBJ beam, column, double wall, form slab, etc., etc. Those settings all have to be in your standard admin and have the value of 1. And once you have that on, all the elements that get the drawings out will, of course, automatically create the OBJ files. And once the OBJ files are there, then, of course, you will be able to get the get all the contents of that. So for now, let us generate column drawings. There's going to be a couple of those columns, not a lot, so we can actually create drawings for all of those. We still have a little bit of time, so that's perfect because we are going to just focus a little bit on the drawings, not a lot. So once those drawings are ready, I'll go ahead and won't update yet, but we'll go back to model view in a second. Maybe we won't be generating the drawings for all the elements. I don't think there's a need. It'll take too much time really for us to get the. So basically all our model now is all saved up. I'm going to update it. And we have our all our elements in, the geometries are in. Of course, it would be good to have something covering this, but maybe it's a bit too much to get the that in a webinar. But while the drawings are generating, let us have a look at, for example, column 1 and see if we already have an OBJ representation of that column. Yes, we do have the reinforcement and casting materials in here because the drawing was created and the reinforcement has also been added. If we go to this beam and click on the OBJ representation for that, you see you get the error that there's no OBJ file ready. So let's focus maybe on just those couple of drawings for us. Okay, it thinks way too long. I was too optimistic about the performance of impact for that, but it's already. It should be good. Okay, so we are free to go. What I'll do is I'll create a drawing for this beam and for this wall as well. So just so it's a bit, just so we don't exceed the time too long. So basically just one beam for us there, and we'll change those. If we go to Project Manager now, basically, if I go columns, select this, OBJ representation, all of those have all of those have the reinforcement now. So that's how you get the OBJ files. That one drawing was already done. Let me go ahead and add the drawing of a wall as well. This one in particular, because it's a shorter one. Just that. Okay, the drawing will be ready very soon, and we'll open just a couple of those drawings. First, we'll start with the column that we've added the reinforcement in, and we'll add some corbel reinforcement automatically to all the columns very quickly, like that. Let me go ahead and actually open the column reinforcement. Click. Let's open this one in particular. Yep, we've got the corbel. We've got the drawing. Drawing is prepared for us. That's that. So that's the typical impact drawing that you all know. And here is the solid view, basically. Right, that's the solid, a 3D solid within our drawing. And that's what needs to be updated to get all the casting materials in. And for us, of course, it's going to be super easy to add the corbel reinforcement. Of course, we've got a bunch of tools to add and edit reinforcement in Impact. If you need to edit a rebar, double click it. It will pop up with a window for you, all the properties. You can edit the dimensions of the element or of the rebar. So of course, go ahead and do that if you require that. Let's go to corbel reinforcement here. And you can select a corbel, doesn't matter if it's in the formwork or reinforcement view, and let's start adding some shape codes for the corbel. A good example, like right here, and of course you can change the spacing of the if you go ahead show clashes, then you see that you can see the clashing reinforcement for our corbel. So you can move the bars around. You can change the cover as well. Cover from front, let's see, go 20 for those bars. Yeah, it might be cover from top 15. That's probably too little. Yeah, for those bars in particular, cover side 15. Yeah, we're moving those outside slightly. No, for those bars actually you need to move inside maybe. So 50, 50, 50, 50. Oh, well, you can play around with that all day long and make sure the clashes don't show. So, of course, I can let's not dwell too much on that. But of course, you can do that. You can change the views as well here to make sure the reinforcement doesn't clash. If you need to add hooks to bars, and of course, you can, for example, do something like this. But that's really up to you whether you want to make sure that everything's correct and perfect. As such, I'm just going to accept that as an example of reinforcement, and I'm also asked now if I want to apply corbel to another corbel reinforcement to another element, and I can, for example, select which corbels I want to have the same reinforcement. Now let's say C2 and C3 for the sake of it, and replace any corbel reinforcement there if it's there. If we go to floor plan again, open up the drawing for the beam, it's going to have some reinforcement as well. And that reinforcement, of course, will be visible in Project Manager. And let's go and open the last drawing. So that's going to be our sandwich wall. Fun fact, you can actually add corbels to walls, which I forgot to show earlier, but we will actually maybe do that in a second. Let's go open that. And that's our full drawing of our sandwich panel, got the sections automatically generated. If we go to project manager, actually go building floor 1, let's add this one and this one, obj representation like that. So that's our reinforcement for the column. We've got some opening reinforcement as well, and our beams, which are identical. So if our beams that are identical have the same reinforcement, then they will also all be updated inside the model. Okay, I would need to refresh the model to get the corbel reinforcement in, but no worries about that. Let's go to floor plan, and let's finish about that one last feature that I don't think we've ever shown. We can actually add corbels to walls. Let's draw corbel. Let's do that. And maybe not at this height, but let's 50. Width, let's go fixed width, let's go 50. And like that. Let's go. Oh, that's the wrong side of it, but yes, let's place that. Exit. And what I'm going to do, because this corbel is silly, I'm going to edit that one. Location. No. Properties. And we need to change the side of that. It's not going to be on the right, but on the front, I think. It should be under placing of lift. Now that's still wrong. I want that corbel to be on the back. Sometimes we get mixed up with this. On the back, exactly like that. Update lifts. Okay, and actually let's move that location and let's move it. Okay. And like that, you get a wall with a corbel. So of course, if need be, to support some elements, and it can of course add more custom materials to that corbel, change its location. So your walls, and basically you can add corbels to anything. If you need to add a corbel to a beam, then you can also do that. That will work. So just FYI, it's there. There's the possibility. But let's go back to our model. Yep, and there it is. Basically, I think we've covered everything that we've had in our presentation. So I forgot about the cranes, which is ridiculous. So let's get back to that. I got so ahead of myself that I totally forgot to do that. So apologies for that. It should be shown in the beginning, but still. There's the option here about cranes, and you can draw a crane, but for that you need to have a crane defined, and you do that in the cranes option. I don't have anything defined for this project, but I have cranes defined in our standard. If I double click that, here's the definition. Of course, let's go back to our, say, create a new crane. Let's say okay. What happens here is basically you define the radius and the capacity at the radius and define the color for that. Basically anything from the AutoCAD colors. So it's as simple as that. And I already have something defined, so I'll just show that, how you place that. Basically, you go to draw crane. That's a new crane 1. There's a definition of it. I want to use this crane in all the building phases, and I want to use it for all the floors. And I need to pick the insertion point for my crane. And say I want to place it here. And exit. And I can accept that. Okay, and for some reason, let me edit that, because for some reason it didn't. Oh, building filter 1. Oh, sorry. I know why. I don't have any radii defined, and I chose the new crane that we had. So yeah, it was messy. Now, there it is. So you can see the radius of the crane and the capacities of that. So Here's our building in scale. I think it's about 10-meter wide building. So we have about a 16.9 radius of a crane arm, and we've got all the radii and the masses as well visible. Of course, you can turn that off, and if you want, you can do a crane check in Project Manager. But within Impact Design, once you place the elements, if, for example, you place the element of a certain mass at a radius that doesn't allow for that, it will pop up with a warning and the element will be immediately marked red. And even if its size is okay in terms of like the production capacity, it will still not be accepted with that. Okay, this is cranes. This is how you add them. It's automatically saved to the database, so it will pop up within Project Manager if you go ahead and actually and place it and update the model. So you can also do crane checks within Project Manager. So without opening AutoCAD, you can verify that all the elements are possible to be carried by a crane in a particular placement. Of course, you can have multiple cranes in a project. So you can draw crane 2, and that's going to be the same one, same phases, and place it maybe at this location and exit. So if there's a bigger area or a bigger building that multiple cranes will need to cover the production of that, because simply put, one crane won't be able to reach all the spots, then of course you can add multiple cranes, and that's how you do it. With that, I think we are now covered. Sorry for running so fast about the cranes. I totally forgot about those. Started with modeling immediately. Kind of went ahead of myself there. But yeah, so we've gone over the crane placement. We've gone over the modeling of elements, the ways of modeling. We've did insert the casting materials as well. We've talked about rebar templates. We saved the elements to the database and mentioned that you can create elements and not really save them in the database, but save them in a separate project for reuse in future projects or multiple different projects. For example, if you have a very complicated geometry of a girder with difficult reinforcement, so you don't have to worry about doing that reinforcement from scratch every single time, or this particular element type every single time, if you will be reusing that for different projects. We've generated sharp drawings. We created OBJ files, and I've shown you how you can create those OBJ files. And we've also previewed the 3D elements in Impact Project Manager. So going back to that, those are our 3D elements. So the reinforcement is not very complex, but it's there. All the casting materials are also there. For sandwich panels, you get all the reinforcement that you would typically do. Of course, if we added reinforcement to that, it will also be visible here. And there you can also see strands for your hollow cores once you create the drawings, but I didn't want to waste additional time on that during our presentation with the number of elements that we had. With that, I would like to thank you all. We did go over time a little bit, but I would encourage you to go visit our LinkedIn profile at Strusoft and our official YouTube Strusoft official channel. So go ahead, like and subscribe to any videos that we have. And of course, go visit our www.strusoft.com website. And of course, from there on, you can also visit our wiki to have a look at all the new features and updates that are coming up with basically every new update, or every couple months. I welcome you to do that. And with that, I would like to thank you all for your attention and see you in the next one.